Hello, we are back again. So in this video, we are just going to be continuing where we left off. So in the earlier video, we saw how we can use Optuna for was it hyperparameter Optuna for hyperparameter tuning, but we are dealing with classification problem. So we are now going to pivot, and for this case, we are going to be using Optuna. And for this case, we are going to be using that for a regression problem. So we're going to see how we can apply Optuna for hyperparameter tuning given a regression problem. Okay. So similar as to what we did earlier, we are going to start. We just import these libraries. I'm going to import the pandas as well as the numpy. Okay. So those are the libraries. We're going to import those. After we import these libraries, we are going to move ahead and import our dataset. So I'm using the read CSV function, df is my variable, then I'm using the head method to print the first 5 rows of the data frame. So this is our data frame. As you can see, we have the different attributes and the data points in these attributes. Okay. Then for the data summary, here I'm just concerned about the null count. So I just want to see if we are missing values so that we can take necessary measures for that. So you can see we have a total of 2095 entries. As you can see, typically we are not missing any values in our data frame. And you can see the different data types for the values in each attribute. Okay. So moving on, we can then move on to the next step, which is about, I'll just be dropping some 2 columns. The first column is the unnamed column and the mileage unit. So I'm just going to execute this, and by this, we'll drop these columns. And then after that, I'm just going to rename some of these columns so that we offer a little bit clarity on what they represent. It's a necessary step, but let's just include it. There is no sin in including it. So while renaming the columns, I'm going to use the rename function, and inside the brackets, I've specified that I'm going to rename the columns in the data frame. And inside the brackets again, I've supplied a dictionary containing the key and the value pair. So the first item will be the original name. The second item will be the name that we are trying to change to. Okay, so we have provided for the necessary columns in our data frame. When I execute this, you can see that we have dropped those 2 columns, the unnamed and the mileage unit column. They are not there, and we have tried to at least change the names of the attributes in our data set. I remember this is a regression model, and you can see that some of the columns in our data frame contain categorical values, and the algorithms that we are going to be using, they won't accept categorical values as input. So we are going to be trying to encode these categorical values and replace them with numeric values so that they can be accepted as input by our model. Okay. So I'm just going to use a simple encoder. So that is the label encoder, just as a simple encoder that will perform that task for us. So when encoding, so I'll just import that model at first. So from scikit-learn preprocessing, we're going to import the label encoder. Okay. Then after that, I'm going to create a list of the columns to encode. I'm just getting a variable columns that will hold the list of the columns to encode. While selecting the list, so you have different options. The first option is to the first option is just create a list, and inside this list you're going to, for example, if I want to change this, I can just first Control V. So you just provide the list of these columns. Okay. For example, fuel, can just do this. The seller type, and just copy this. and then we just paste in here. So this is one way that you can do while creating the list of columns that you're going to encode. But when dealing with a data set that contains many attributes, for example, if you're dealing with a data set containing many attributes, trying to create a list like this won't be a viable option. It will take much time. So what we do is to select these columns with respect to their data types. So you can see under the data types, we either have an integer, object, or a float. Okay, so integer and float, these are numeric values, but object is you can say it's a string. Okay, so we're just going to select the columns that have object as the data type. Okay, so that one kind of isn't that task for us. So we are going only to include the columns or the attributes that contain object as our data type inside for in the variable column, so that that variable will hold those columns that we're going to encode. Okay, after we are done with that, we then move on to create a copy of the original data frame. So basically with this step, I just want to encode the column or the attributes that contain categorical values and leave those that contain either numeric values. Okay, so to avoid that confusion, so we're just going to create a new copy of the original data frame. And by that, I'm using the copy function, so I'm just copying this to our new data frame data called data. Then after this, we initialize the label encoder. So this is we're creating a dictionary that will store our values. Then while doing the label encoding, I'm using a for loop. So for call in columns. So columns, remember, is this. So this is the variable that is containing our the columns that we're going to encode. So for call in columns, then we create an instance of the label encoder, this one here. Then after that, the next step is all about doing the label, doing the encoding. So this step is about encoding. So we are using the fit transform from the label encoder. And after we are done with that, remember that we did create a copy of the original data frame. So we are just trying to retrace our footstep going back. So we are copying the columns into our original into the df, and then we execute this cell. It's going to take some time. When you execute this cell, as you can see, the columns for the columns are name, fuel, seller type. So name, fuel, seller type. You can see we have performed our encoding, and the other columns were not nothing happened to them. Okay. So after we have done the label encoding, you can now see that our values are numeric. So with this, we can then move on to the next step. And the next step is all about importing the necessary modules that we will be using during this process. So those include the train test split, the standard scaler, the XGB regressor, the random forest regressor, model selection, the cross validation score, that it will be helpful. Then in terms of evaluation, again, you can use either the mean absolute error, the mean squared error, or the R squared score. So depending on the different evaluation metric that you decide, so you can choose one or two, or you can use all of them. Okay. So after we have imported these modules, the next step will involve us defining the features and the target variable. So at first, I'm going to drop all the null values. So if we have null values, we can drop them. Then for the features, these are the input features or the dependent variables. So we are going to create a new a variable for that. That's the x. And then for this, in our data frame, we're just going to drop the column price. This is the target variable. So we're going to drop that, and the rest of the columns will be under a new variable x. For the target variable, we are dropping that here, and we are only specifying that we're only selecting the column price as our target variable. Okay. After we are done with this, doing this, after defining our input features or the independent and the dependent variables, then move on to the next step, which involves training and doing the split. So we are splitting our data into training and the testing set. So you can see X here is the dependent features, Y is the target variable. Then we are specifying the test size. 30% of our data will be used for testing, while 70% of our data will be used for training. Then we can supply the random set, which is just the seed value. So you can use any value you want. It's not a must use 42. We used to use in 42. Okay. So when we execute this cell, we'll have done the train test split. Then the next step will be about the standard scaler. So we use this, we create an instance of the standard scaler. So scaling, we're trying to squash these values. As you can see in our data frame, we have different attributes have a different scale, or the magnitude of the values in those attributes varies. And when we are going to train our model having this variation, then it's going to affect how our model performs. So using these values the way they are, then it means that our model will likely give preference to attributes that do have their values are high in terms of magnitude. So to avoid that, so we are going to use this standard scaler to try and squash those values so that they are within similar range. Then after we initialize our standard scaler, we then feed and transform the training data. Feed and transform the training data, that's the X-train. Then after that, we just use the same scaler, but we transform the testing data. Okay. Then after this, we move on to let's get an example of how we can build a regression model that is going to predict the price of cars. Okay. How do we usually create a model? For example, using the XGB regressor that will enable us to predict the price of cars. Okay. So I'm using a function, so I'm just creating a function that will enable us to do that. So I'm defining a function, then inside I'm passing in the parameters. So XL scale, Y10, XS scale, and the Y-test, these are the parameters or arguments. Then at first we need to initialize our regression, the regressor model. So XGB regressor, then we supplied some hyperparameters with different values. So for example, in estimators 30, random set 42. Okay. Then after we're done with that, we go ahead to fit the model to the training data using the fit function. And these are the fit arguments that we're passing in. So we're going to fit our model on the training data. So basically we're trying to tell our model, this is the training data. So go learn some few tricks here and there between the relationship between the dependent variables and the target variable. So learn some relationship that exists between those two. And after we have learned that relationship, come back and make predictions now using the new set of data that we have supplied. Okay. So after making those predictions, then we need to go ahead and try to evaluate the model. How is our model performing based on the data that we have provided? So in regression, we have different types of regression. We have different types of evaluation techniques that you can use. You can either use the mean absolute error. You can use the R-squared score. This one is the mean absolute percent. Just do a quick search. So this one is mean absolute percentage error. Okay, that's also another evaluation metric that you can use to evaluate your model. I can also have the mean squared error as well as the root mean squared error. So these are the different types of evaluation metrics that you can use. Then after we defined our objective, our function, we are going to return the evaluation metrics. We are going to return this. After we return this, we are going to use the same. Now we can, assuming we have defined the extent and this and this and this, we can then use we can then use the evaluation metrics now on our data and then print out our results. So when we execute this, these are the results that we're getting. So you can see that the mean absolute error after for our model is about 48,759. The R squared score is about 0.90. So 90% is 90% of the variation. For the mean absolute percentage error, you get this value, mean squared error, and the root mean squared error. Okay, so this is how our model is performing. Okay, so the next step is all about now seeing how we can try to improve our model so that it can generate a good scores in terms of when we look at the how the model is performing. So that's where and when we try to improve the performance of our model, there are many things that we can use, but with respect to what we are discussing today about hyperparameter tuning, that's what we are going to be focusing on. And we are going to use Optuna library. It's going to guide us or help us try to do hyperparameter search with the need or with the goal of trying to improve our model. Okay, so when using Optuna, at first you need to import Optuna. Okay, so you're going to import Optuna. Then after that, as we saw earlier, we need to define the objective function to be optimized. Then suggest hyperparameter values using the trial object. Here, a float value of x is suggested for example -10 to 10. So with this example, okay. So for XG boost regressor, these are the different hyperparameters that you can use. In estimators, we have provided the search space, so 10 and between 10 and 100. For the max depth, 3 and 10. Learning rate, subsample, good sample by tree, the gamma, reg alpha, reg lambda, and the random state. Okay. So this random state is used for reproducibility for the model that you're trying to build. So after we have defined the parameter space, we can then move on to initialize the XGB regressor. For the regressor, we pass these parameters. These are the argument we are passing inside the regressor model. Then we fit the model to the entire training data set. As you can see, and after fitting, we make our predictions and then evaluate the model on the testing data. We are using the mean absolute error. Okay, so this is it. And then we are going to return the mean absolute error test. Okay, so I'm going to execute this. So after executing this, this is where now we are going to this is where now we are going to create a study object and invoke the optimize method. So depending with the number of trials that you can pass in. So we are getting a study. We are creating the study. We are getting a study object. So we are creating a study object to invoke the optimize method. So we are creating that, and this one is the optimization now, where it takes different types of arguments. One including the objective, the number of trials, and you can display progress bar to see how the search is taking place. and the end jobs. Okay, so for the creating of the study, so this one also takes different arguments. So one that I will be looking at is the sampler. So for the sampler, a sampler object that implements a background algorithm for value suggestion. So if we are using none, if none is specified, then we are going to use the Optuna.sampler TPSE sampler. But if you want the other type, you can use this one. Okay. In the classification module, try to use this one. The classification module. So with respect to this, and let's say for example, passing and for the direction, we're trying to minimize the mean absolute error. So that's why we use this minimize. Okay. And after that, we print the number of trials. Then the best trial is which one? And there's the best trial for that. Then we print, I think this one will be, by this we are going to print the parameters for that of the best trial. Okay? So when we execute this one will take a little bit of time because remember we are doing 100 trials. So let us be patient and wait for the training to take place. And after it's done, we'll get the best parameters for that. So currently we are at about 1244, 51. So I think it's moving a little bit fast. Trial 64. Let's give it time. So when that is running, then we are going to get the best parameters for the trial params. Then you are going to create the best parameters. Yeah, so after getting where we are, 84, 95, 96. So the number of finished trials is 100. Then the best trial value is this. In terms of the mean absolute error, the best trial value is about 46,203.44. So that's the best trial for that. And then it gives you the different hyperparameters and the respective values. Okay? So with this, you will be expected after getting the hyperparameters and the values, you're expected to now create the final model using these hyperparameters. And so the conventional way of doing that is that I'm going to, let's say for example, XGB model, then recall B model, then I'm going to recall the XGB regressor. Then the conventional way is that I'm going to now, for example, n estimators, I'm going to copy this and then pass it in here and then start doing this. I think it's something like this. So by doing this, I think you'll be quite slow in what you will be doing. So the best way is to create a new variable and just, and in this variable, it will store something like a dictionary. And this dictionary will help us just pass those hyperparameters as a dictionary to the new model that you are trying to build after doing the hyperparameter search. So I'm just going to copy this into a new cell. Then just do away with this. Then for the best params, what I'll just do, I'll try to print this. So when we execute this cell, you can see that we are creating something like a dictionary, and this dictionary is containing the hyperparameter and its value, hyperparameter and its value. So it saves us the time that will be needed to, let's say, type this or copy this and paste, copy and paste. So it saves us that time. So After these are the best parameters now in form of a dictionary. So to save us that time, we're just going to initialize the regression model with the best hyperparameters. So we pass it like this as the best hyperparameters. Since we then the random state 42, then we fit the model on the entire training data. By doing this, then we make predictions of the testing data. Then we make our evaluation and then print the evaluation metrics. So when you execute this, it's going to take some time. These are the results we are getting from that. So the mean absolute error, the R score, the R squared score, you can see we have, I think from about 90. From about 90 to about 90, 91.5, 91, 92%. Okay. So you can see that after using that model, you have tried to improve our regression model. Okay. You can also, this one we used the mean absolute error. We can use another. You can use another. For example, if you want to use this for the R squared score, so nothing significant changes. So you can just copy this. Just say for R squared score, if you want to use that, so you can copy this. So everything will remain the same. We're not going to change that. So here, where we can change this, instead of mean absolute error, we change that to R squared score. So we can just call that this one. This, and try to paste where here. You can just paste it here. Okay. So this one will return the R squared value. So if you are interested in this, so we can execute this. Then after we are done with that, we can then create this study that will do the optimization. Then this one will just direction to minimize, to maximize or minimize. Let's use minimize. Then this one will remain the same. Number of niche trials, all this. So so oops, there's something we are missing here. Is supposed to be this one. Need to end this process. This one need to end it, and copy this so that it just starts fresh. But the results that we're going to return is the R squared value. Tested trial, number of niche trials, direction minimize, objective. I think everything is okay. So we'll just wait for the training. I think just wait for the training to take place. So when it's done, then we can also get the best the best parameters. And just do this in here, then go back here and do the same. Just add another one, paste it here. So let's see, are we done with the training? So we are at about 12:41. So this one will take a little bit of time. We're just going to wait and see final results. So we'll just give it some time and wait and see. Of course, if you're going to the number of trials, if you are going to use for the number of trials, if it's going to iterate having the number of trials as a huge number or a huge value, it's going to take a lot of time to do the iteration process. But if, for example, if you use 10, this process will be over. Okay? But I think as you increase the number of trials, so does finding the best hyperparameter. The probability of you finding the best hyperparameter also increases. So let's see where we have reached. But it's done. To minimize red out. Let's say to maximize squared value. Because we want highest that is closer to 1. Okay. So for the number of trials, let's do 50. Let's see what we'll get from this. It's going to take some time, so let's give it some time. As you can see, when we used so we're trying to maximize the R squared value. So you can see now, for example, like this one, the best trial is 3 with the value of this 0.9, okay? 0.97, 0.97. Proceed 0.97, 0.91, 0.91. We are now at trial 32. Let's give it some time. We're now at trial 40. Okay, so we can now see that the best trial value is this. Okay. 91 point about 0.91. The best parameters are this, and when you can execute this, you can run this again. These are the values you can see. You can see with this value, we have also decreased the mean absolute error. Anyway, so that's it. That's how you can apply Optuna a given regression problem. So this one was just for XGBoost regressor, given different algorithm, for example, the random forest extra trees, the decision trees, all those algorithms do have different hyperparameters. So this hyperparameter search space will definitely change when you use a different algorithm. But with respect, in terms of the steps that we are trying to take, generally will just remain the same. And this process, I've tried to do some automation of this process so that it saves you time when trying to build a new model using the new hyperparameters. Okay. So once again, that's it for my side. Thank you for your time. Until next time. See you. Bye bye.